Hello, this is our CPE 187 final project. It's called Super Simon, which is modeled after a popular game. The team members are as follows. My name's Josue Marroquin.
I'm Thuong Nguyen.
And my name is Ibrahim Arshad.
So, for this project, we split up our responsibilities between the core game logic, which included the firmware, the button, as well as the LED. The next part that was split was the buzzer implement. The buzzer was what was in charge of creating the tones for unique sounds of the LEDs. And then the final part that we integrated was the actual UART interface, which allows the user to receive feedback as the game is playing and records the memory of the record of the game as it's being played.
Here's the full flow of our assignment game. We begin in the menu state where the game waits for any button press. As soon as the player presses a button, the game starts. Next, the game enters the show state. Here, the MCU plays back the assignment sequence using the LEDs and buzzer. The speed adjusts based on the level, so it gets harder as you progress. After the sequence is shown, we move into the replay state. This is the player's turn to replay the sequence using the buttons. Each button press is checked against the stored pattern. If the player gets the sequence correct, they pass the level, and instead of going to fail, the game jumps back to show, where a longer and faster sequence is displayed for the next level. If the player gets the sequence wrong, the game enters the fail state, and an error animation plays. And once that completes, it returns to the menu so the player can try again. So the main loop is menu to show to replay, and then either pass and back to show for the next level, or fail and back to the menu to restart.
Here's the randomized sequence generate in the code. So each level of the game increased by one sequence length, stored in an array, maximum at 50 steps. So the game getting harder over time. Uh, the randomized length will the randomized sequence will increase by C standard library rand, and the timer is millisecond timer. Give different sequence on each reset. Every entry sequence will be between 1 and 4, which connect uh, which mapping from 1 to button 1, PC6, and button 2, PC7, and button 3, PC8, and then button 4, PC9. So should go next. Our STM32 button debounce preface. Each button keeps 16 shift resistor history. When we press the button, only when 16 and 12 slash 16 sample are stable, the there will be an input, else it just ignore. This handle zero mechanical bounce and electric noise from the button itself. Uh, Continue.
So for the buzzer, we used a passive buzzer, which allows different frequencies to create different tones. This is a single tone buzzer, and it's reacting to a PWM signal. The reason this works is the simple circuit diagram shows that there's a transistor, an NPN, that allows us to be frequency sensitive, which was great for us because that means that we could use the time handler to generate the PWM, and by adding the prescaler and generating a making it a 1 megahertz signal, we can then use the tones to further step it down to get a 1 kilohertz or 2 kilohertz tone, allowing us to give unique sounds and tones to each button sequence, as well as certain events, such as a fail. So for the tones, we used 880, 988, 1047, and 1175. Those each assigned to each unique LED. The commands used were the void buzzer on, buzzer off, and then the buzzer set frequency. Those were implemented anywhere where the LEDs were turning on and off, since each sound was already being tied to the LEDs.
So for the UART support for the game, uh, first we initialized the USART3 at 115,200 baud. Inside the USART3 UART function for 8N1 communication with TX and RX enabled. Then there was also the two helper functions to make sending text easy, the URWrite and the URPrintf. And so whenever the game enters a new state like menu, show, replay, or fail, we call the UI functions that use UR to print information. So basically we integrated the UR3 into the project and added helper functions for sending text and built a full terminal interface for the game. Everything the player sees on the screen is transmitted through UART using the functions that I added.
So for testing the state machine transitions, we wanted to verify that the game flow was happening the way that we had previously defined. Where there's a menu, you initialize the showing the sequence, and the user has the opportunity to enter the correct sequence. And if they do, they replay, and if they don't, it fails. So what we did was, after building the code and building the circuit, we just, at each transition state, we verified that the intended action correctly moved the state machine into the next state, and that those states continue to cycle until the appropriate exit action. So for the menu to ready, it was any button being pressed at the start. From ready to show, it was the blink animation, that the sequence being generated. The show to replay was the moment that the user would get to press buttons. The replay to show would be only if they entered the correct pattern. If they did not, then we would move to fail, or if there was a timeout and they did not accomplish the sequence within a time limit. And then finally, if a fail did occur for any reason, it returned to menu to restart the game. This is a demo of the actual buzzer working. There's a video embedded here, but we thought we could give a live demo, so we're going to transition to that. So right now I already have the code running. Sorry. Right now I have the system already connected through the UART. And what we're going to see is that when we press a button, so right now it should be in menu mode, which is what the UART is telling us. And if I press a button, we transition to the show, in which I get to enter the sequence. And if I succeed, we go on to the next sequence, which was the replay. But now if I get the sequence wrong, it shows a fail, and we've returned to menu. And it does store the high score as well as the current level, so you can see that the current level is reset to 0.
To end things off, we would like to talk about the things we would do differently or change in the future if we were to ever to do something like this again. For me personally, I was assigned the UART, and our original goal was to use the screen, but I had a lot of difficulty with using the screen. Uh, I would have communicated with my teammates a little bit better and decided on a different plan sooner, which we eventually did do, just to make sure that we were able to complete the project in a timely manner.
For
Uh,
future improvements on the buzzer, I think what would have been useful is using multiple buzzers. Single tone buzzers, no matter what frequency you play them at, they're all pretty unpleasant. So being able to play multiple tones and actually creating something that was pleasant to listen to, or moving from a buzzer to an actual speaker and being able to play all kinds of sounds rather than a single tone or even two tone.
um, for me, the improvement I should do on the game flow and the LDM button is transition from the show to replay. These are small bugs. If I press the button too fast, it will not blink and make sounds. So that's the only thing I need to improve on that part. That's all for me.
Okay, yeah,
Six,
and that
16
was
minutes.
the entirety